Hello viewer, in this tutorial we will continue with the centroid problem, that means locating the centroid of a given plane lamina, that is two-dimensional surface. And we recall our memory regarding the steps of locating the centroid. The first step is divide the area into elementary areas, and this will be necessitated if and only if the area or the plane lamina happens to be composite in nature. That means a composite lamina is one which is made out of several elementary areas or elementary figures or elementary let us say small surfaces whose centroid can be readily located. For example, triangle is a elementary area, elementary surface. So also rectangle, square, rhombus, etc. And verify if the given plane is symmetrical to any of the axes. For example, if the given figure is symmetrical with respect to x-axis, we need to find x bar. If the figure is symmetrical with respect to y-axis, we need to find y bar. Of course, whenever we find either x bar and y bar, a reference axis is a must. And if it is S, we need to find and if the figure is symmetrical with respect to both the axes, we need not have to find the centroid, because the intersection of the symmetrical axis would only lead to the centroidal location. And if it is not symmetrical with respect to any axis, we need to find centroidal location or location of the centroid, both horizontal direction and vertical direction. That means we need to find the two coordinates, one along x-axis or one along x direction, the other one along y direction. So we will go with the problems, and in the previous tutorial we have discussed about two elementary problems, one T section and one I section. Now we will continue with the problems. Now the third problem is something like this. It's a channel section, and here it is neither symmetrical to x nor to y. We can see that because we are unable to draw an axis. Therefore we need to axis which is symmetrical. Therefore we need to find out both x bar and y bar. So this is the way that we recognize whether a figure is symmetrical or not. Okay, we will be unable to draw an axis which will balance both the sides, or we will not be able to find an axis with respect to which we can fold the figure into two mirror images. Now then, after having identified the asymmetry of this figure, we need to draw two reference axes, one in this corner, the other one in this corner. Other one here is the reference x-axis and reference y-axis. For a moment we should assume that this entire figure is glued with respect to the reference axis. And now soon after we find the centroid, we can just shift these axes to that centroidal location, so that there will be a balancing act. So the figure will be able to balance itself with respect to centroidal x-axis and centroidal y-axis. So choose the reference axis. We have done that. We will divide the area into three parts. One, the horizontal rectangular portion, the vertical rectangular portion, and three, the horizontal rectangular portion at the bottom. Now A1 of the first figure is 20 into 1. Here the dimension is 20. This is 20 into 1. And x1 is 10 centimeters. From here, x1, the centroid of this particular elementary area is somewhere over here. It is at half of 20 centimeter. Therefore, it is 10 centimeter. And y1 is 24.5. And because here till here, it is 25 centimeters. And we will reduce 0.5 over here because centroid of this is over here. Therefore 25 minus 0.5 will give us 24.5. As far as A2 is concerned, it has 23 because one goes over here, another one thickness goes over here. So what we are left with is 25 minus 2. Therefore the height from here till here, the area number 2 is 23. Therefore it is 23 into 1.5. The thickness is given to be 1.5. So that will give us 34.5 centimeters square. And x2 is from here till here. It is half of 1.5 centimeter. That will give us 0.75 centimeter. And y2 is from here till the center of this. The total height is 25. half of 25 is 12.5. Therefore the centroid is somewhere over here. We will just mark the centroid for the sake of clarity. Okay, centroid of this portion is here, the centroid of this portion is somewhere over here, and centroid of this portion is somewhere over here. So this will now our life will be less miserable now, and we will find A3. A3 is 30 into 1, 30 horizontal dimension, 1 is the thickness, so or the depth 30 centimeter square, and x3 is half of 30, that is 15 centimeter, and y3 is half of 1 centimeter, that is 0.5. Now we will straight away apply the equations for x bar and y bar, and x bar happens to be a1 x1 20 into 10, a2 x2 that is 34.5 into 0.75, a3 x3 that is 30 into 15 divided by a1 plus a2 plus a3. It will get us the x bar distance from this particular reference axis to be 7.99, which can be approximated to 8, and y bar is once again 20 into 24, 24.5, a1 into y1, a2 into y2, and a3 into y3, and a1 plus a2 plus a3. So we have got y bar to be 11.1. It's very important to locate this centroid after knowing x bar and y bar over the original figure. So here it is, x bar is this distance, that happens to be 8 centimeter, and y bar is this. Now we'll go for the fourth problem. Fourth problem is a typical Z section. This is seemingly symmetrical with respect to x-axis, but no, because this length is 150 millimeter, this length is 300 millimeter. Of course it is not a proportionate drawing, but anyway 300 is bigger than this, therefore there is an asymmetry. So this figure is neither symmetrical to x nor to y, and the thickness of all these sections happens to be 20 millimeter, that is given to be 20 millimeters. So we will break the area into composite figure into three parts. One horizontal rectangle, 1, 2 is the upright rectangle, and 3 is again horizontal rectangle, and we will have the reference axis both x6 and yy glue to this particular position and at the bottom over here. Now we need to find area 1 into x1, area 1 into x2, y1, and area 2 in comma x2 y2, and area 3 x3 y3. Like that we will separate them with respect to the reference axis for the sake of clarity. So here is the reference axis and here is the first area. So this is 150. So it's better, in order to have ease with our calculation, if the dimensions are in millimeter, let us convert them into centimeter. It takes just division by the given value of the distance or the dimension by 10, because 10 millimeter makes 1 centimeter, therefore 150 by 10 becomes 15 centimeter, so 15 by 2. Now the values will be reduced, and our calculations will be very concise and very crisp. So it is 15 by 2, 7.5 centimeter, and here till here, as far as y1 is concerned, from here till here, up till here, it is 600 millimeter, that is 60 centimeter. 60 minus 2 by 2, that is because this is 2 centimeter, 2 by 2, half of 2 centimeter, because the centroid of this, it's better, we will just mark it again for the sake of clarity again. So here is the centroid of this horizontal rectangle, the upright rectangle is somewhere over here, and as far as this is concerned, it is over here. The centroids of the elementary areas. Now after having known this area and y1 and x1, it's only calculation. A1 is 15 into 2, 30 centimeter square, x1 is 7.5 centimeter, y1 is 59 centimeter. Now as far as area 2 is concerned, it looks something like this. So it is 60 by 2, because here till here it is 60 by 2, and this distance is since the width is 2 centimeters, it is 2 by 2 plus 13. So 13 plus 1, 14 centimeters as far as this location of this particular individual centroid is concerned of area 2. So A2 is 56 into 2, 112 centimeter square, and x2 is 14 centimeter. From here 13 plus 1, 14 centimeter, and y2 is 30 centimeters, that is 60 by 2. As far as this area is concerned, the bottom area, which is numbered 3, so the x distance is 13 plus 30 by 2. This is 30, so 30 by 2, 15. 13 plus 15, that is 28 centimeters. As far as this is concerned, the thickness is 2 centimeters. Therefore, 2 by 2 will give us 1 centimeter. So now we know the area. Area is 30 into 2, 60 centimeters square. X3 is 28 centimeter. Y3 is 1 centimeter. This is Y3 and this is X3. So now we have gotten all the areas of 3 elementary figures as well as their corresponding centroidal distance with respect to reference axis, both in the x direction as well as in the y direction. It's only computation of the centroidal distances with respect to reference axis. X bar is a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. It will give us 17.2. On the other hand, y bar is 30 into 59 plus 112 into 30 once again. That is a1 y1 a2 y2 a3 y3 divided by a1 plus a2 plus a3. That will give us 25.7 centimeter. We will mount the figure over here with respect to reference axis, and x bar is 17.2 from here, so it's over here, and as far as y bar is concerned, it is 25.7. so centroid is located. Now locate the centroid of the given figure. So this is this figure is once again neither symmetrical to x nor to y, and it consists of a rectangle, big rectangle measuring 8 by 6, and there is a quadrant of a circle. There is a hole which has the shape of a quadrant of a circle, and here is a triangular area. Therefore we can consider the big rectangle to be 1, and we will have the reference axis, one over here, other over here, for the sake of reference. So when we find out the centroid, we can just move them so that the area will get balanced with respect to centroidal xx and centroidal yy. Here this is the area of a1, that is 1, which measures 8 by 6, and the centroid is over here. And this is a2, the quadrant of a circle, centroid is over here. 4r by 3 pi vertically, 4r by 3 pi horizontally. And this is the triangle, and the centroid is over here. It is base by 3 from here, or 2b by 3 from over, 2/3 of base from the apex, or 1/3 of the base from here. So we will just go on calculating. The plane section is symmetrical. A1 is 8 into 6, the big rectangle, 48 centimeters square. X1 is half of 8, that is 4 centimeters. That is, this distance is 4 centimeters. And Y1 is 3 centimeters, half of 6. And as far as A2 is concerned, it's a negative area. It's a negative area. Pi 2 square by 4. It should have been 4. It's not 2. Yeah, this is 4. Yeah, pi 2 square by 4 minus 6.28, and x2 is 4 into 2, 4r by 3 pi, this distance x2. And as far as this distance happens to be 0.84, y2 is also 4r by 3 pi, that is the vertical distance from the reference axis, that is also 0.84 centimeter. But the area here happens to be negative because it's a punch of quadrant of a circle shape. And A3 is of that triangle, half base is 4 and height is 6. Height is 6, so 12 centimeters square. X3 is this 4 we have got because the here till here it is 12. 12 minus 8 is 4. So X3 is 8. X3, that is this distance from here, from the reference axis. We have to cross this rectangular width, that is 8 centimeter, and we have to move further to 1/3 of base. So it is 8 plus 1/3 of 4, which will give us 9.33, and y3 is 6 by 3. It is 1/3 of height, or 2/3 from this apex. Anyway, we need this distance because our reference axis is over here. So this distance is measured, this distance is measured as far as triangle is concerned, and this distance is half the dimensions of the rectangle, and this is 4r by 3 pi and 4r by 3 pi vertically. So we will just put the values that we have gotten into the basic equation. a1 x1 plus minus a2 x2 plus a3 x3 divided by a1 minus a2 plus a3. Yeah, we have got 5.6 centimeters. In the same token, we can calculate y bar. A1 y1 minus a2 y2 plus a3 y3, and sum of the areas with negative area over here minus, so it will give us 3.03 centimeters. If you plot this over the original area, here is a quadrant of a circle. The original figure is not proportional anyway, and here we have written a proportional figure, of course not to scale. So here is the centroid, 5.6 centimeters from the reference y-axis and 3.03 centimeters from the reference x-axis. We will go to the actually this should be, yeah, right, fifth problem. Okay, that doesn't matter. Fifth problem, locate the centroid of the given figure. Here is this figure is something like this. It is once again asymmetrical. The reference axis is already given. There is a quadrant of a circle measuring a radius of 100 millimeter, and there is a semicircular hole created in quadrant of a circle. A plane is a quadrant of a circle. In that, a semicircular hole is created. Since the radius of this is 100 millimeter, since this is semicircle, the diameter of this semicircle would become 100 millimeter. So it is an asymmetrical figure. We need to find both x bar and y bar with respect to reference axis. Both x bar and y bar are to be located. Now, a1 is pi r square by 4. R is 100. So pi r square by 4, we have got this. Anyway, we could have reduced this 100 millimeter into 10 centimeter in both the cases, okay? But anyway, x1 equal to y1. Since it is quadrant of a circle, it is 4r by 3 pi from this end along the x-axis and 4r by 3 pi along y-axis. It will give us 4 into r is 100 divided by 3 into pi, 42.44 millimeter. And a2 is a negative area, of course, 50 square, pi r square by 2, because it is a semicircle. The radius happens to be 50 millimeter, and it will get us an area of minus 3927 millimeter square, and x2 is 21.22, 4r by 3 pi, and it is somewhere over here. Okay, we will once again mark this for the sake of clarity. So here it is. This distance is 4r by 3 pi. Vertical distance is the radius, and as far as the semicircle is concerned, it is somewhere over here. Sorry, quadrant of a circle, 4r by 3 pi vertically, 4r by 3 pi horizontally. So I got x2, we have got a2 is a negative area, it's only, and y2 is 50 millimeters, exactly half of the diameter, that is radius. Now we will substitute all the values that we have computed, and a1 x1 minus a2 x2 divided by a1 minus a2 will give us 63.66 millimeter as far as x bar from the reference axis is concerned. In the same token, y bar is 7854 a1 into y1 minus a2 into y2 divided by a1 minus a2. So it has given us 34.88. Now we will just plot this. So from this reference axis, x bar is 63.66, and from this reference axis it is 34.88, and it is over here approximately, and this is 34.88 y bar, and this is 63.66, that is x bar. Okay, locate the centroid of the given figure. So wherever it has become centroid, kindly read this as given lamina. Okay, here is a semicircle. Within the semicircle there is another semicircular hole, semicircular punch. Of course, this the radius of this is smaller than this, obviously. So now we need to it is symmetrical about y-axis, because we can fold this figure into two mirror images. So symmetrical about y-axis, we need to find y bar. So a1 is pi 5 square by 2, because the radius is 5, 39.26 millimeter square, and a2 is pi 3 square by 2, it is minus 14.13 millimeter square, because it is a punch. There is no area. So how to formulate this area which is not present? By putting the minus sign, that's all. So y2 is 4r by 3 pi y2, this one, this height, it is somewhere over here. So 4r by 3 pi, and so it should be y1, sorry, should be y1, not y2. So this is y1. y1 is 4r by 3 pi, r is 5 centimeters, of course. And y2 is 4r by 3 pi again. The r here is 3 centimeters. It may be somewhere over here. So therefore we have got all the required ingredients for computing y bar, and y bar would suffice. So y bar is a1 into y1 minus a2 into y2 divided by a1 minus a2, and the distances are measured, distances are computed, and it is placed over here in the basic formula, and we have got y bar to be 2.6 centimeters, and it will come somewhere over here. So 2.6 centimeters from the reference axis, reference x-axis. Okay, locate the centroid's coordinates of the centroid for this given figure. Here is a big circle within which a small circular hole is drilled or punched. So this is 10 centimeter radius. The big circle is 10 centimeter radius. Obviously this circle will have 10 centimeter to be diameter from here till here. So now we know the dimensions, and this is the reference axis because it is symmetrical with respect to x-axis. So we can fold this figure into mirror images. So y is the reference axis attached tangential to this particular end, at this particular end. Therefore we need to find out the distances. a1 pi r square, that is 314.16 centimeter square. a2 pi into 5 square, pi r square, because the diameter is 10 centimeter, the radius would be 5. So minus 78.53 because it is a punch, there is no area. x1 is 10 centimeter from here till here. So this is the centroid of the circle, and here is the centroid of the another circle. So that is 15 centimeters. From here till here it is 5, from here till here it is 10, 10 plus 5 is 15. Therefore a1 x1 minus a2 x2 divided by a1 minus a2 will give us 8.33 centimeters. Therefore the centroid will come somewhere over here, which is at 8.33 centimeters with respect to y-axis and along the x-axis, because the figure is symmetrical with respect to x-axis. Now find the centroid of the lamina, which is something like this. And here there is a quadrant of a circle, there is a punch which is of the shape quadrant of a circle, and it is being made over a square measuring 3 centimeter by 3 centimeter, because the radius of quadrant of a circle happens to be the side dimension. If you move this radius, it will be parallel to this particular side, and the length is 3 centimeters. So it is a symmetrical figure. Therefore we have divided the entire figure into two parts. One is a square 3 centimeter by 3 centimeter, other one is a quadrant of a circle of radius 3 centimeters, and this is the reference axis, this is the reference y-axis, this is the reference x-axis, and we need both the axes because we need to find out both x bar as well as y bar. So the figure can be constructed something like this. Out of a big square of measuring 3 centimeter by 3 centimeter, a quadrant of a circle is made. So what remains with us is this particular portion, which looks like a triangle, but it is not a triangle. The shaded area is obtained by deducting quadrant of a circle from a square. Right, lamina is asymmetrical, therefore we need to find both x bar and y bar. And a1 is, that is the area of the circle, square is 3 into 3, 9 centimeter square. x1 is 1.5 from y-axis, and y1 is 1.5 from the x reference axis. Now we will find a2 is pi into 3 square by 4, quadrant of a circle, minus, it receives minus sign because there is no area like quadrant of a circle, and x2 is 4r by 3 pi, x2 from here till here, this is 4r by 3 pi, and this is 4r by 3 pi actually, but we need this distance with respect to x-axis. Therefore we will find this value, and we will deduct this particular value from 3, because from here till here it is 3, and here till here it is 4r by 3 pi. Therefore 3 minus 4r by 3 pi will give us the y distance of the centroid of the quadrant of a circle from the reference x-axis. So y2 is 3 minus 4r by 3 pi. This is 3 minus 4r by 3 pi will give us 1.27, that is 1.73 centimeters. This is actually 1.73 centimeters, and this is what from here till here upwards is what 4r by 3 pi is. Now x bar is 9 into 1.5, so a1 into x1 minus a2 into x2 divided by a1 minus a2. It will give us 2.34 centimeters. So as far as y bar is concerned, a1 into y1 minus a2 into y2 divided by a1 minus a2, and we have computed everything. So the y bar from x reference axis is 0.66. If we happen to locate this, it will fall somewhere over here. So horizontally at 2.34 centimeters from y axis, and vertically at a distance of 0.66 centimeters from the x axis. And we have this particular problem. There is a circle within which a rhombus shaped hole is punched. Therefore there is a negative area over here, and this figure is symmetrical with respect to x-axis. It can be folded with respect to x-axis. Now we need to find x bar. Therefore since we need to find x bar, we have to have the reference axis which is parallel to y, or y-axis. So we will find out a1. Centroid of the circle is over here, centroid of the rhombus is over here. Since this distance is 10 centimeter, this will be 5 centimeter. Okay, we will just compute that. a1 is pi r square, that is pi into 10 square, big circle, 314.16, and a2 x1 is 10 centimeter from here till here. Now a2 is 2 times, there are 2 triangles, one over here, one over here. Therefore 2 triangles, half base is 10 centimeter, height is 5 centimeter, because this diagonal also measures 10 centimeter, it being a rhombus, and we will have this also to be 5 centimeters. So now this area is negative, and x2 is 10 plus 5, that is 15 centimeters. So from here till here it is 10 plus 5 is 15 centimeters. Now we will apply the formula. X bar is a1 into x1 minus a2 into x2 divided by a1 by a2. a1 minus a2 will get us a value of the coordinate axis, coordinate value of 9.05 centimeters. If you happen to plot this, it will come somewhere over here. It is 9.05, because here from here till here it is 10. So proportionately, if proportionately sketched, it will be coming somewhere over here. With this, we have completed this tutorial, the second tutorial on centroid, and I will come up with the third tutorial on centroid with little complex problems. Until then, bye. And if you are not subscribed to my channel, kindly do that. Thank you.